So to find the degree, you would add up your exponents. Now keep in mind that when you have a constant, you have to have an actual variable for it to have a degree of 1. So this 2 is just a 2. If it was a 2x, then that would count as a 1, an exponent of 1. But this is just a 2. So we're just adding our exponents, which would be a 2, a 3, and then what's the exponent on this factor? 1. Go ahead and add those up. So your degree is 2 plus 3 plus 1. And what is 2 plus 3 plus 1? 6. All right, to find your x-intercepts, you're going to set your factors equal to 0. So take the x minus 1, set that equal to 0. Take x plus 1 and set that equal to 0. And then take x minus 3. So go ahead and do that to find your 3 x-intercepts. So you would get, what would be your first x-intercept? 1, 0. Your second x-intercept? Negative 1, 0. And your third x-intercept? 3, 0. All right, now to find your y-intercept, and I'll go to the top of the screen so people can see in the back. To find your y-intercept, the definition of y-intercept is the y value when x is 0. So if I take this function, f of x is the same as y equals 2. And now I'm just going to rewrite the equation, except every place where you see an x, I want you to put a 0. Oops, that's a cube, sorry. All right, let me make sure I wrote that correctly. So 2, and then you have 0 minus 1 squared, 0 plus 1 cubed, 0 minus 3. So you can type this in your calculator if you need to, or you can just figure out what that would be. So let me see. I try not to use a calculator. So we have 2 times negative 1 squared times 1 to the power of 3 times negative 3. So that is going to be 2 times positive 1 times positive 1 times negative 3. So did you get negative 6? Negative 6. So your y-intercept would be at 0, negative 6. So your y-intercept is at 0, negative 6. So we have our degree. The degree is 6. We have 3 x-intercepts. And we have our y-intercept at 0, negative 6. So I'll give you a second to copy that down, and then I'm going to have to erase some stuff to give myself some space. And we'll do our limits. So for your limit, first of all, are the arrows going to go the same direction or opposite directions? Same, because it's a 6 degree and 6 is even. And this 2, is that a positive 2 or a negative 2? So that tells me that both sides will go up. So whenever it's the same, you can write it as one limit. So the limit of f of x equals, as x approaches positive and negative infinity, because it's a positive 2 and because it's even, both sides will go towards infinity. And that would be your limit. Your end behavior expresses the limit. So before we do that, though, let's just talk a little bit about imaginary numbers. So we're starting 4.6 for those people who are titling your notes. This is the last new piece of information that'll be on the quiz next Wednesday. It's complex zeros. So we're kind of going out of order a little bit in chapter 4. So 4.6 is complex zeros. You don't really have to write this down. The main thing that you want to say, that I would, if you want to summarize it, this is the definition of conjugate. This is the conjugate pairs theorem, which is also in your book. But just know that a complex root always comes in pairs. Okay, if you have one, you have the other. So if there's anything from this slide I would write down, I would just write this piece. That's really important. Just know that if you have one complex, you're going to have another complex. You can't have an odd amount of complex roots. Complex roots always come in pairs. Okay, so let's go ahead and copy down these 4 examples, or this example 1, and then we'll find the conjugate pair, because this represents one complex root, and we have to write the other one because they always come in pairs. So I'll give you a second to copy that down, and then we'll work through it. Okay, so keeping in mind what that theorem says, if you have A plus BI, you also have A minus BI. So notice what is changing here is that middle sign. That's how you form your pair. So what do you think the pair would be for 3 plus 2i? 3 minus 2i. What about the pair for negative 4 minus I? Negative 4 plus I. Now for C, there's an invisible 0 right here. So if you have a negative 2i, if you have 0 minus 2i, you also have 0 plus 2i. But if it's a 0, we normally just drop that. So we'll have plus 2i, or positive 2i. And lastly, negative 3 minus 5i. So that's really important because now we're going to do some long division where we have to find remaining zeros, and at least 2 are imaginary. So let's hit it. So we'll start off with a 3rd degree function. So go ahead and copy down example 2. So how many solutions am I looking for? 3, because it's a 3rd degree. So I like to put my x equals. I'm looking for 3 solutions. And they told us that one of our solutions is negative 5i. And because I know that negative 5i has to have a partner, what is my automatic second solution going to be? Positive 5i. So we already have 2. We just got to find that third one. And to find the third one, we're going to do long division. Okay. So let's talk about imaginaries just a little bit. How do we get this plus and minus 5i? The only way to get this as a root is if I have a factor of, so I'm going to do a little bit of like algebra 1 real quick, and then we'll go back to this. Is if I have x squared plus 25. If I have a factor of x squared plus 25, then I know that I'm going to get these 2 roots. So if you have x squared plus 25, let's just go through it. I would subtract the 25, and then I would have to take the square root of a negative 25. I would take out the negative, and then I would separate that. This would become an I, this would become a 5, and that's how we get the plus or minus 5i. Okay? So that's really important to realize, because if I see that I have this as a 0, then I know that x squared plus 25 is the factor that I'm going to divide into it. I'm not going fast. You all can write it down. It's okay. It's all right, guys. It's all right. We got time. We got time. So that's really, really important. So let's just, before we start doing our division, if I knew, let's say the 0 was, they said the 0 was 3i. What do you think the factor would be? How would I get a 3i? X squared plus 9. If the 0 was 4i, then my factor would be x squared plus 16. Okay? That's really important that you're able to identify that factor, because that's what we're going to do long division with. All right, so now that we have that, let's go ahead and get started with our long division. So let me take that off. So we have x squared plus 25. And we're dividing that into, so x squared plus 25 comes out here. And we're going to divide that into this function. So I'm going to go pretty slow. And the steps would be to, let me write the steps too. The steps for long division is to divide the first term. So we did synthetic division. Now we're doing long division. Divide the first term. And then you're going to take your answer and multiply that, and then change both sides and add. Change signs, add. That's just my abbreviated steps. Change sides. Then add. Okay, so that's my very, very abbreviated steps. So we will probably be finished tomorrow or at the beginning. I'll give out the study guide Friday for the quiz. But this is the last new piece. All right, so when I say divide the first terms, I'm talking about literally the first terms, which in this example would be x cubed by x squared. So I want you to take the x cubed. If you take x cubed and divide that by x squared, what would you get? X. Put that x on top. Step number 2 is to multiply the x by your factor. So take the x and multiply it by x squared plus 25. So x times x squared plus 25 is going to give you x cubed plus 25x. So you want to line this up with this like term. So I'm going to put my x cubed here. So after I divide it, this is what I got. And then I'm going to multiply. This is what I get. Now line these terms up. So x cubed would go here. 25x would go here. And then the third step says change signs, then add. So this x cubed is going to become negative, and the 25x becomes negative. Okay, so now we're going to repeat. So these will cancel because x cubed minus x cubed is 0 and 25x minus 25x is also 0. So now we're going to bring down this term here. And we're going to repeat those steps again. So when we repeat it, we're going to start by dividing our first term, but our new first term would be this 3x squared and this x squared. So let's divide 3x squared by x squared. So what is 3x squared divided by x squared? What does that give you? 3. Put a plus 3 on the top. Now take this 3 and multiply it by x squared. So 3 times x squared is 3x squared. And then 3 times 25. 3 times 25 is 75. Change both signs. Change. These both cancel, so we have a remainder of 0. So I know I did that right because I ended off with 0. So this is my last factor. So set this factor equal to 0 to get your third solution. So if x plus 3 equals 0, so this is my last factor. X plus 3 equals 0, so that means that x equals negative 3 is a root. So my 3 roots are x equals negative 3, x equals negative 5i, and x equals positive 5i. You could also say x equals plus and minus 5i. All right, I think we have time to do one more. Yes. Oh, it doesn't matter. So I like to line up. So you see how this is x to the first? I just like to put it on top of the x term, but that's just my math OCD-ness. It doesn't matter. Okay. All right, last example for today. Let's go ahead and copy it down. So we're going to do one a little longer. It's a 4th degree. So if I have 3i, what do you think the factor is that I'm going to divide into this? X squared plus 9. So you're dividing this by x squared plus 9. So your first step is going to be to divide your first terms, which would be x to the 4th divided by x squared. What is x to the 4th divided by x squared? So I'm going to put that right here. And I'm just lining it up with the x squared, but you could put it anywhere. But I just like my exponents to be lined up. So I'll put my x squared here. Step number 2 would be to take that x squared and multiply it by x squared plus 9. And that's going to give you x to the 4th plus 9x squared. Notice how I'm lining up my like terms. All right, so now you're going to change both signs. So this becomes a negative and this becomes a negative. And let's add. So when you add, this cancels out. We're going to bring down that x cubed. And what do you get here when you take 7x squared minus 9x squared? What do you get? Negative 2x squared. And I'll just go ahead and bring down everything else too. So now we're going to repeat. We're going to divide the first terms. So my new first term is x cubed. I'm always going to divide by x squared. That doesn't change. So now you're taking x cubed divided by x squared. So if you take x cubed divided by x squared, you get x. Put that plus x on the top. And then take that x and multiply it by x squared plus 9. So when you do that, you get x cubed So x cubed. And then what's x times 9? That's a 9x. So I'm going to put my 9x here. Change. This is going to cancel out, and this cancels out. So the only thing left is my negative 2x squared and my negative 18. So we have to do this one last time. Divide your negative 2x squared by x squared. What do you get? Negative 2. Put that on the top. And then you take negative 2 times x squared plus 9. So when you distribute that, you get negative 2x squared, because negative 2 times x squared is negative 2x squared, and then negative 2 times 9 is negative 18. We do our change. Do we end off with a 0 at the end? Okay. So now you need to solve this factor, this quadratic. So take this that you have at the top and factor that down. So take x squared plus x minus 2 and factor that down. So we figured out that, so we have x squared plus x minus 2. You can make a box, but you don't need to make a box because a is 1. You just need to find your two numbers that multiply to be negative 2 but add to 1. So what are two numbers that multiply to be negative 2 but add to a positive 1? Wait, what is it? 2 and negative 1? Positive 2 and negative 1, is that what you all got? All right, go ahead and set those equal to 0. So your zeros would be, our four solutions are x equals negative 2, x equals positive 1, x equals positive 3i, and what's the last one? X equals what? Negative 3i. And that is that.